Okay, so in this presentation I'd like to show you how we are going to access to the features of the project, of the platform of the project. In this way I'm going to show you the three main components of the architecture, which are the MSO portal, the monitoring, and the orchestrator. Okay, so about the portal, it's going to be the main entry point of the end user, of all the human users. We want to be, of course, user-friendly, and it's going to be composed of different services, which the most important are a software marketplace, in which we will be able to see all the different applications and all the different mathematical frameworks that we can use that are already in the system. Also a data catalog in which we're going to be able to browse or surf between different data, not only input data but also output from the different simulations. This part is going to depend on the application that they want to publish their data or not, of course. We're going to have pre and post operations with a graphical interface embedded in the portal. So we will be able to see the outputs and the inputs and also perform different operations over them. Of course, we are also be able to execute the simulations or the applications. We will be able to monitor the infrastructure and the executions. So we will be able to see how the HPCs and the virtual machines are working, and also the applications that are running. We will be able to see if the execution is going well, is going bad. We'll be able to stop them, change its parameters, and well, interact with the simulations. And finally, we'll have some learning tools, tutorials, question and answer tools. Also, we will integrate probably the tutorial or the documentation that it's been doing in the work package 4 and 5. Okay, this is the high-level architecture of the portal. I won't be very technical. Just for you to know, we'll have an authentication and authorization component, which will allow us to use different organizations or different communities inside the portal. So let's say, for example, if you're working with petrol, maybe the data you publish, maybe you want that everyone has access to it and things like that. We'll have the front end, which is going to be the main landing page of every user. And as I said, it's going to be connected with different components of the data catalog, as I said, a visualization tool to visualize the data, also connected with pre-post processing tools, marketplace, the monitoring, and the experiments management tool. As you can see, the portal is going to be connected with the monitoring and the orchestrator. Okay, as we just started with the development of the portal, I'm going to show you some pictures in order to give you a whole picture of how the portal is going to work. This would be the marketplace. In this case, every organization will have access to a catalog of software resources. In this case, I've put Phoenix, Field++ as an OPM, of mathematical frameworks. And also the floating wind turbine. Okay, from this we will be able to choose the components that we are going to work with or that we are going to provide to our own organizations inside the portal. Okay. Well, it will going to have the typical features of a marketplace. We can charge for some of the features if we want. We will also have other different features, as for example ratings, comments over the software, things like that. Well, and also once we acquire a software for our organization, we're going to be able to use them, selecting, I will be talking about that a bit later, selecting them to run the mathematical frameworks or the applications, and also register our own applications. For example, if we have Field++, but we are developing an application using Field++, where we will be able to register here, okay, inside the organization. About the data catalog, we will be using CCAN, which is a component of FileWare. The data repository is designed in a way that, for example, well, this is an example of OPM. In this case, what we want is not to copy every different repositories of every people into a common repository of us. Instead, we're having a catalog which is going to be connected with the different actual repositories of the different partners or the different users of the application. With this catalog, we will be able to register our data. We will be able to tag the data, so then we can search, we can filter this data, we can put metadata or useful information of this data to use it then in the simulations. And well, license, it's using the DCAT format. Well, it has these features. We can talk about that later if you are interested. About the experiments tool or the experiments management tool, it's going to be the part of the portal that actually is going to run the simulations. As Christoph said, this is going to be the workflow operation or a high-level workflow. Firstly, we will select the software we are going to use. We will select the data from the catalog that we want to use as an input, and also we'll select the different inputs depending of the application. For example, in Phoenix, you could select the number of iterations you are going to run, for example. Then this is going to be sent to the orchestrator and the monitoring part, and what it's going to do here is to deploy the execution in that way. For example, well, if we have an application, we are going to copy the data from the repository to the HPC. Maybe, for example, we have the application in GitHub and we need to build the application in the infrastructure, or copy executables or binaries from other parts. We want, for example, to create virtual machines. For example, if we want to run different things in a cloud environment. While we have this and all the deployment has been done, we're going to run the simulation. Okay, in this part, the orchestrator is going to be working with the monitor to take smart decisions on, for example, how a specific job or a specific part of the application has to be run. For example, let's say we have 3 HPCs and one of them has a high load in that moment. For whatever reason, the orchestrator can decide to put this job in another HPC or things like that. It's going to communicate with the monitor, and it's going to allow human interaction. The monitor is going to be showing this information in the portal, and a human or the end user is going to be able to stop the simulation or rerun it in a different way, or interact, okay, with the simulation. And finally, when the simulation is finished, we'll be able to check the results, check logs, executions, data information, the outputs, everything, okay? Also, the outputs will be published in the data catalog we said before. In this workflow, there is not pre and post operations, but of course, we will be able to do it. So before select a data input, for example, we'll be able to do a pre-processing in the portal, also with the data generated. Okay, this is something similar as what Carlos showed you before. This is going to be how the monitoring part in the portal is going to be shown. It's using Grafana. In this way, each organization or each application in an organization, it's going to be able to have its own dashboards on how or their monitoring. For example, let's say an application, it's going to have some specific metrics that it's not going to be in other application, or for example, for some end user, a metric is going to be more important than for other user. So users is going to be able to build different dashboards to see actually what is happening with the simulation, okay? Well, also we're going to be able to have alerts. Let's say a simulation runs during 5 days. If you don't want to be in the computer all the time, or anything happens, or something like that, the end user is going to be capable of creating alerts for their simulations. For example, let's say, the infrastructure, let's say an HPC it's offline for a while. You can put an alert or some specific metric of a simulation. You can set a threshold and say, for example, send me an email if these thresholds, things like that. Well, this is just the same as the alert manager, just to show the alerts is going to be presented in the portal, of course. Okay, about the pre and post processing in the portal, we will be using different tools. In this case, this is ParaView. In a way, we will be integrating web tools. For example, ParaView has a web version. And also we're going to use virtual desktops or remote desktop integrated into the portal in order to perform this application. So instead of have to install this application in your computer, copy the data and things like that, you will be able to run it directly in the portal, selecting the data. Okay, this is another example. Velocity. Okay, but the learning tools, basically we are planning to have 2 of them. One is AskBot, with this, which is this. It's like a Stack Overflow, Stack Exchange, things like that. The user will have karma. There are going to be administrator users or expert users. The idea here is to have a dynamic place in which end users or new users could, or for example developers of applications using the mathematical frameworks will or can ask questions and be answered quickly, and also publish for others to check. In the same way, we're planning to use Moodle as an academy inside the portal, something like that, in which we will have tutorials. I don't know, we can have courses if we want, different universities or things like that. It's very flexible. I imagine you already know it. If you have questions about this, you can, okay. Okay, that's all for the portal part. Well, this is a lot of, I think I'm saying a lot of different things. I don't know we have, if you have a question. If not, I'm passing, okay, to Orchestrator. Okay, in this part, if you remember the original architecture, this is the lower or low behind the portal layer. In this case, we'll have the orchestrator and the monitoring. This layer is going to actually run the simulations and check what is happening, okay? The orchestrator is going to deploy and execute the simulations, and as I said, it's going to execute it smartly somehow. About the monitor, is going to provide information to two ways. One is going to be the orchestrator, and the other to the portal, okay, to the humans. This would be a more technical architecture, just to show you, well, how all of this is going to work. The portal, when we select the data and we select the software and things like that, it's going to, it's going to produce a blueprint, okay, of the execution, which is a Tosca file. I'll explain this a little bit more. This Tosca file is going to be received by the orchestrator, and the orchestrator is going to first do the deployment into the infrastructure, which is going to be different HPCs and also different cloud providers, and also it's going to be connected with the monitor to check measures first from the infrastructure and also of the executions. The monitor is going to be connected directly with the infrastructure to know what is happening, and mostly that is all. As you can see, the monitor is also reporting to the portal, so the end user is going to be able to send again different blueprints while the orchestrator is running in order to change the simulations. This is something is not already designed, but we have to decide how exactly the user are going to interact with the simulation, but it's something we plan to do, okay? This is the same I told. Okay, so all of this is really nice, but at the end, how the mathematical frameworks are modeled or introduced in the system, and how the applications are introduced in the system. If you are a newcomer in this project and you have an application, how could you integrate in our system? Well, as I said, we are using Tosca. Tosca is a description language. Maybe you know it. It's similar. Well, it's a YAML language. It's similar to JSON and things like that. It's very simple, and we are not extending, but we are creating verbs or words in this language in order to easily model the different application or the different mathematical frameworks in the system. In that way, the mathematical frameworks will be modeled using Tosca, the applications, and also the inputs. As I said, these are text files. In order to have a more graphical way to develop this modeling, we're planning to use Alim4Cloud, which is an open source tool, which is going to, well, it allows us to draw the application with boxes and things like that, and then Alim4Cloud is going to traduce it into text files, okay? And also Alim4Cloud it will be integrated in the portal. Okay, I'd like to show you some examples of these Tosca files in order to show you how different things can be modeled in the system, and these things will be then used by the orchestrator and the monitoring part. In this case, this is the Tosca file, and this is the graphical view of this Tosca file. We have FT2 node, which is representing an HPC. In this case, it's representing the Finisterrae infrastructure, and inside it we have another node which is called single job. As you can see in the Tosca file, we have FT2 node, which is of type HPC nodes compute, and we have the single job, which is from type HPC nodes job. This is the language we are developing using Tosca in order for end user or developers of application to use it to model their application. In this case, well, I think it's clear. All the infrastructure things are going to be of type compute, and all the different tasks or the different components of a model are going to be jobs. As you can see, for example, we can set here different inputs. In this case, I'm putting the credentials of the HPC in order to connect and talk to it. And in the job, I'm going to put the jobs option. For example, here I'm telling him that we are using srun. As you can see here, I said that the HPC is a slurm type. It's using the workload slurm. So these are the typical inputs of a jobs. For example, let's say we are not using a slurm and we are using another one. We could still have this kind of options, and the orchestrator is going to actually run it in the different workloads. Also, we have the relationships important. In here, we said that this job is going to be contained in an HPC, and the HPC is FT2, for example. I want to show you this. Okay, I'm connected here to the Finisterrae 2. As you can see, I don't have right now any jobs, and I want to show you how the orchestrator. Well, something I haven't told you. Right now, the monitoring part, as we are developing it, I'm not able to show you it right now because it's not connected with the orchestrator. In this sense, right now the orchestrator is doing itself simple monitoring in order to the orchestrator to be able to work. Okay. Okay, I've made a little script in order to be easier to show you this demo. What I've done right now is to send single blueprint, which is what we saw before, to the orchestrator. This is going to be done when we register a new application in the marketplace. Okay. I want to show you now this is the web interface of the orchestrator. Okay, as you can see right now, well, this is not going to be shown in the portal, but just so you know, the orchestrator right now is aware of the blueprint single job. Okay. This, as I said, this is what. Okay. This. Okay, so let's say we have already this single job application in the marketplace. It's acquired, and now we want to do a deployment. To do a deployment, what I'm doing here is to pass to this blueprint. I'm going to pass it different inputs. In this case, I'm passing the inputs of the Finisterrae 2, and yeah, and so, I think mostly that. Okay, if we see right now in the in the deployments, I have here this deployment, This is the topology of the deployment, okay. As we can see, we just created a deployment, but this deployment is not deployed or is not installed in the HPC. Right now, we are only telling the orchestrator that this is the deployment we want to do, okay? Next thing I want to do is, well, as you can say, anything happened yet in the HPC. Right now, I'm going to create the deployment. What's doing here is in the Tosca file, I haven't put any deployment mechanism. So right now, it's not doing really anything. If I had put it, for example, a deployment script, I could have deployed anything here. For example, let's say a script that builds some software, copy something from here to there, etc. Things like that. In this way, I'm not doing nothing because I'm just running an srun command. Okay. Here in the website, we can see that the orchestrator, okay, already deployed or installed the deployment into the HPC. And finally, I'm running the jobs. I have a deployment, the deployment is installed in the HPC, and now I'm telling him, okay, the single job, now you have to run it. Here it's queuing the HPC job. It's connecting to the login node of the finished array. The task just started, and task succeeded. Right now, the orchestrator is monitoring the HPC. If we see here, the finished array 2, now we have a job that is completed. It's very quick. And the orchestrator, in this case, just finished, okay? It has monitored the single job and just is telling us that the task finished, okay? That will be the workflow of an execution. Of course, all of this I'm doing from an script. At the end, that's will be doing by the portal, okay? Now I want to show you a more complex example. Oops, this is not. Okay. Okay, this is a more realistic example. In here, you are telling, using the Tosca file, that we're going to have a finished array as infrastructure, and inside it we are going to run 4 jobs, which 2 of them are going to run in parallel, okay? Let's say, for example, the first jobs could be, I don't know, well, different things, okay? This is the Tosca file. Probably you don't see it very well. We have, well, the finished array is not here, but we have 4 jobs. And if we can see, we have, for example, the first job, which is, all of them are of type HPC nodes. I have the first job is of type S-batch, of Slurm. I say is contained on the FT2 node. I have the second and third parallel jobs, which have 2 relationships. One is that is contained in the FT2 node. I'm telling the orchestrator that it has to be run in that HPC, and also I'm saying that depends on first job. The same for the third job, and the fourth job is depending on the third and the second. Again, if I run it, here I'm uploading the blueprint. This is something that's going to be done the first time we put an application in the portal. Then I'm setting the inputs here. Okay, deployment is created. Now I'm installing the deployment. Again, in this case, the deployment is doing nothing because I haven't put any script about deployment. As you can see, the deployment is following the same structure or the same graph. First is going to do the operation of the finish Terra 2, then the first job, then second and third, and finally the fourth here. As you can see, we have here only the completed job, and now I'm going to run this dummy simulation. Okay. You can check that the orchestrator just started the first job inside the HPC. If we go here, we have a new job, okay, which is first job in cola corta, which is pending right now. Hopefully this is going to be quick enough. Okay, as you can see in the orchestrator, well, you don't see it, but it's doing the monitoring right now. Okay, it's checking. In this case, it's 30 seconds. It's checking the status of the job, and if the job is finished or completed, it's going to run the second and third in parallel inside the HPC. Let's wait a second. Okay, it's completed. Let's see. Okay, the task has finished. Okay, and now it's running third parallel job and second parallel job. Okay, it's running it. If we see in the orchestrator, okay, we have here two new jobs, third and second. Okay. While this is still running, I want to show you maybe the most interesting example. Okay, so those were dummy examples in order to show you how the orchestrator works and how these Tosca files works. In this case, I want to show you how we could model with Tosca a mathematical framework and then an application using this mathematical framework. I showed you before what is called node templates in the Tosca language. In this case, to model a mathematical framework, instead of templates, we are going to use types, node types. So I'm saying here, I'm going to have one job, which I'm calling it Phoenix iter, which means an iteration of Phoenix, and it's going to be derived from HPC nodes jobs, so I'm telling the orchestrator that this is a job. As a properties, I'm going to set it that it's going to have iter number, to say it's the first, the second, the third, etc. And also, I'm going to put here some jobs option. For example, in this case, I'm saying that this jobs is always using this command. Also, I'm putting here another type of job for Phoenix, which is called Phoenix post, to do post-processing of Phoenix. In this case, I'm telling him that it's also a job. It has iter number to do the post-processing on the proper iteration. It's going to have a file, so which file I want to do actually the post-processing, and also the job option. In this case, I'm using here the same command. So this could be the mathematical framework model in the portal, model using this Tosca file. If we are developing an application, for example this one, in this application I have two iterations of Phoenix, and I have already acquired Phoenix, and I have these models, okay? So I'm saying, okay, this is my application. In my application I'm going to run one iteration of unicorns, then I'm going to run two post-processing, and also I'm going to run a second iteration. Okay, so what would be my Tosca file? It would be first the FT2 node. We're telling it that we are running all of it in the HPC, in the Finisterra HPC. And then I'm going to define the first iteration job as type HPC nodes Phoenix iteration. I'm going to say that the iteration number is 0. And well, I put here as an example deployment properties. In this case, as this is an example, I don't need to deploy anything because I already deployed manually in the system. But let's say I need, well, in this case, I need to build the software, to download it from GitHub. And create some folders and things like that. In this case, I could put all of this in a deploy.sh script and tell the orchestrator that the deployment is going to use this file with these inputs. Okay. Then I have the first velocity post and first pressure ports, would be these two jobs. I'm telling in this Tosca file that those depends on the first iteration, and also I have the second iteration which also depends on the first iteration, and for example the second velocity post-processing which is depending on the second iteration. If we send this blueprint to the orchestrator is going to run first iteration 1, then it's going to run in parallel those 3 jobs, and when this job is finished, it's going to run these 2 jobs. Okay, let's say for example we need to run 1000 simulation. We don't have to do all of this 1000 times. In this case, we will be able, not right now, but we will be able to put Finisterra 2 as a first box, and then another box which is going to be, for example, these 3 points, and it's going to be, okay, these 3 jobs, you're going to be running it 1000 times, okay? Things like that, all of this can be done in the Tosca file. Let's see if the other job finish. Okay, just simply I want to show you. First it ran the first job here, then when he finished ran the third and second job, and both of them finish at the same time because they are dummy jobs and they are not doing nothing, and finally it ran the fourth job. If well, I'm going to run just for you to show you the Phoenix. No, not here. I'm going to run you the Phoenix example, but we won't have time to see it because it ran for several hours. But just okay, uploading the blueprint, deployment created. Now I'm installing the deployment, so all the different deployment scripts that I would put in the Tosca file is going to be run in this stage. It's creating the node, connecting to the HPC. If we, for example, we want to copy input data, it would be that moment. If we for example, need to build software or for example, create different virtual machines, it could be that moment. And finally, starting the, as you can see, the first iteration it's going to be, it's been running right now, and we can see the first iteration in the HPC. Okay, you can see here the first iteration is going to be run for 3 hours or so, and then it's going to run the 2 post-processing and the second iteration. Okay, to finish, okay, that's well, I'd like to tell you finally different functionalities that I haven't shown you right now, but we are developing this moment. For example, containers or standalone execution. I've only run standalone executions, but in the same way the orchestrator is going to be able to run with containers, in this case Singularity probably. Victor will talk about that later. Also simulation interaction. I haven't interacted with the simulations right now in these demos, but it's going to be possible. Also, as I said before, iterative execution. So if you have different loops or things like that in your application, it can be done in the orchestrator. For example, one functionality that I think is nice is to be able to run different simulations at the same time with different parameters in order to see which goes better. Also freedom to choose HPC infrastructure or not. In this case, I've run all of this in the Finisterra 2. In the future, for example, you could have a node that would be generic HPC, and the orchestrator will decide where to execute what. And also, I've only run jobs in the HPC, but in the future we will be able to use virtual machines from cloud providers. Okay, that's all from me. I don't know if you have questions. I think maybe it's a lot of information. So, okay.